Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at Ethernet frames. We'll be discussing Ethernet encapsulation, data link layers, MAC sublayer, data encapsulation, accessing the media, and finally, Ethernet frame fields. This episode is part of my series on Introduction to Networks for the Cisco Certified Networking Associate, or CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Ethernet operates in layer 1 and layer 2 of the OSI model, the physical layer and the data link layer. It is a family of networking technologies defined by IEEE standards 802.2 and 802.3. The 802 standards, including Ethernet, use two sublayers to help us transport data: the LLC sublayer and the MAC sublayer. The LLC sublayer places information in a frame to identify which network layer protocol is used for the frame. The MAC sublayer, responsible for data encapsulation and media access control, provides data link layer addressing. IEEE 802.3 data encapsulation includes the Ethernet frame. That is the internal frame structure. Ethernet addressing includes both source and destination addresses to deliver the frame from Ethernet NIC to Ethernet NIC on the same LAN. And finally, Ethernet error detection uses a frame check sequence, which is calculated by using a cyclic redundancy check, and that is placed in the trailer for error detection. It is error detection, not error correction. Error correction happens at the upper layers. Media access control for the IEEE 802.3 MAC sublayer includes different Ethernet standards for different media. Fiber has its own standard, wired copper has its own standard, wireless has its standard also. Legacy technologies including a bus or a hub. These technologies were half duplex and use contention-based methods. Remember, contention-based methods here was the CCNA CD, collision sense multiple access collision detection. So it detects when there's a collision, waits a random amount of time, and then sends that data along. Ethernets today use switches that operate in full duplex. Full duplex meaning communication happening in both directions at the same time. Ethernet switches do not require access control through that CCNA CD collision detection, because once again, communications happens in both directions at the same time. They both have their own lane to send that data back and forth. The minimum size for an Ethernet frame is between 64 and 1518 bytes. The preamble, the beginning of that Ethernet frame, is not included in that total. Any frame smaller than 64 bits is considered a collision or a fragment. Any frame bigger than 1500 bytes, that's considered a jumbo or a baby giant frame. If the size of the frame that was transmitted is either bigger and smaller than that, the frame is dropped. Dropped frames typically are the results of collisions or other unwanted signals in your lines. They're considered invalid. It was my pleasure to provide you with this wonderful episode on Ethernet frames. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks. Once again, I'm Kevin. This here is KevTechify. I'll see you next time for another great adventure.